Otherwise, the product remain liquid.
So okay.
The product is a liquid product that
It's a
is
liquid
easy to apply.
Yes.
But in this particular case, the solution works only when there is a contact with metal and the absence of oxygen. Otherwise, the product remain liquid.
So okay. So when here there's air, so it's not doing anything. There's also
Nothing
no metal.
happening here.
Nothing happening.
Also,
but the moment it touches metal and you take away air,
exactly.
Then it starts to do magic.
Start the reaction. Start the.
Okay, you have to tell us what
chemical reaction. Then I will show. I will explain a bit more how it works.
Okay, so let's see this.
How to apply? It's easy to apply because it's one click.
It's
better to move.
Better to move it away. Let's do that there so we can see it better in the camera.
It's sufficient to apply a ring of product all around the pipe. From
and you applied at the end, not there. Okay.
No, here.
There,
because when I assemble the parts, I can distribute it in a better way. Beautiful.
Right.
It's only a ring. Take the second part and assembly.
Let's do that over here so we can see that.
Is why I started from the second one. Because
so it kind of
pushes,
the fact
exactly.
it pushes the liquid as it goes there.
Exactly. Exactly. In this way, we cover the surface. The product that is liquid adapted to the surface for the roughness. And then at the end, start the curing, start the reaction, the chemical reaction, and became a sort of solid plastic that cover 100% and seal properly all the surface.
Okay, so now this thing is there, and so this one is actually, it's a good test here. We have this one lying here that it doesn't touch metal, that has air. This one is inside there, touching metal, having no air.
Here is in contact with metal, but also in contact with oxygen. That means that outside remain liquid also. What there is inside start to react, start to become this type of plastic, change the status and become more efficient.
So that means, so now the reaction is happening.
Yeah.
How long does it take to react normally?
I show you.
Okay.
When the product, I prepare a couple of pictures to demonstrate.
Okay.
When there is the product in contact with air, that is this case. The product never react.
Okay, so this is what we're seeing here.
Yeah, exactly. When you close the product between two metal surfaces, start a chemical reaction that is what's happening here. Inside the resin, inside the product, there are some monomer, the peroxide, and oxygen. That is exactly what's happening here. When the product starts to be in contact with metals, the metal ions that are present in the surface of the metal start to interact with the peroxide and create a sort of free radicals that are the starting point to create the chains of monomers. And when it's close between two parts, in absence of oxygen, the monomer start to connect to the free radicals, increase their length, and create a lot of cross-link because start to continuously react till there is a liquid part, becoming something that is really solid, a very cross-link.
Okay, so that means basically the absence of oxygen and the presence of metal causes them to do this. What I would like to know is, I mean, what is actually, are they reacting with the metal? So is the metal different after that, or are they changing their form such that, now they are positively charged or negatively charged and now attracted to one another? Well, how does the actual...
All the metal normally, if as an active metal, exchange metal ions.
Ion exchanges happening there.
Is exactly what's happened when there is an oxidation on the surface.
All right. Okay.
Because there is a metal ions that is in contact with the oxygen. That in that case create this change of status with oxygen.
Understood.
In this case, the metal ions start to connect with the peroxide that is inside the resin. And start to react. Is something similar, but is a different type of reaction, and is why the performance mechanical resistance, and also the speed of reaction change based on the different type of metals.
Okay.
Because if it's inactive, it's faster.
Yeah.
If it's a completely passive metal, is a bit more longer in terms of reaction.
Okay. So this one is still reacting, and it probably will change color when it's finished. Okay, that's
when it's react, became a sort of white plastic.
This is always the nice part about the chemistry, you know. It's turned blue. Okay, it's fine.
You can start from different colors, but at the end.
But actually, we like that, for hydrogen applications, because that then makes it easy to know: is it safe? Has it worked?
Exactly.
Did it not work? Okay.